Welcome to Photonics in Focus, the podcast where industry leaders and innovators share insights into the latest advancements in integrated photonics technology. Join us as we explore how this emerging technology is transforming industries and driving new possibilities, and how AIM Photonics is at the forefront of this revolution. Tune in to stay ahead of the curve in the rapidly evolving world of photonics. Today, we're joined by Christopher Streimer, Director of Test Assembly and Packaging Operations at AIM Photonics, and Anthony Aiello, Photonics and Test Engineer. In this episode, they discuss how the Institute's advanced testing and metrology services support technology development at every stage, learn how early-stage testing can save time, reduce risk, and improve results, particularly in a field where precision, performance, and reliability are essential.
Hi, Anthony. Thank you for joining us. All right, let's start with the basics. Can you give us an overview of AIM Photonics testing and metrology services? What kind of tools, capabilities are available here?
Sure. Well, we offer test services to both internal and external customers that have compatible pad sets and layout with our probing capabilities. Well, we have an open services agreement where customers can just join us with tests, and it can be ongoing pretty much as long as they need to satisfy their testing. They could also do a standard one-time quote with us. And we also have a new test service offering that's going to be released soon, where customers can pick from a few different tiers of test groups based on how many number of die or reticles they require to be tested, as well as what type of testing. So for instance, if they require passive testing, DC, active testing, or RF testing. And these measurements can include anywhere from basic insertion loss, as well as active insertion loss across O, C, and L bands, as well as DC electro-optic testing of modulators and photodiodes. We also do laser LIV characterization, and this can be temperature dependent. RF electro-optic small signal measurements, we could do those up to 67 gigahertz. And we also perform bit error rate and eye diagram information up to 64 gigabaud. And that's with NRZ, non-return to zero, and ham4, which is pulse amplitude modulation. And we can do these measurements both manually as well as fully automated with an electro-optic prober at the wafer and die level. And we have a wide range of industry standard test equipment, such as tunable laser systems, various test instrumentation, and we are continuously expanding our capabilities based on our customer test requests and feedback we receive from customers. We're also planning on adding a visible test setup in the future. This will kind of help with some quantum applications that we're starting to see, as well as a laser ring and line width capability.
It sounds like there's a lot of flexibility in terms of how to engage with us, including what you had mentioned, a standard service that could be booked, at the time of submitting designs for MPWs. All right, testing during the prototype phase can sometimes be seen as optional. What would you say to those customers who might be tempted to skip or delay the testing phase?
Yeah, I would highly recommend they not do that. Testing at an early stage allows the customer to discover any good or bad problems within their devices. The real measured data of semiconductor optoelectronic devices does not always match simulation results. And, project managers should always allocate enough budget for this testing.
And it sounds like, by not allocating that type of budget, there's a penalty to be paid later on with redesigns and additional delays. The
redesigns are very costly and expensive, as well as time-consuming. You're going to wait several months between runs when you could have figured out these issues ahead of time and avoided that.
Absolutely. What kinds of measurements or analysis are especially valuable to those who are new to photonic integrated circuit design and development?
I would say just start with very basic measurements. This is passive lightweight measurements with just a swept laser source, power meter, and polarization control. That's all you need to get your feet wet and get a baseline understanding of waveguides, rings, modulators. Customers also learn to incorporate, other debugging tools in their circuit. You need loopbacks for alignment when they're testing, splitters to give you feedback on each individual component. So a customer may have a complete circuit, but you might need to characterize or debug the individual components throughout that circuit. So adding things like photodiodes, taps, splitters, you can kind of separate the circuit into individual parts, test each one along the way. And then once you have passive insertion loss, you can kind of move on to active testing. Just add a little bit of DC bias to the modulators, to heaters, junctions, thermal optic phase shifters, and start to understand how this circuit behaves when you add voltage or current. And then you can also add a simple signal generator and an oscilloscope. And it doesn't have to be high speed. You could just modulate these circuits at megahertz frequencies, and just to get baseline understanding on how things operate. And this includes modulators, photodiodes, and even lasers that are directly modulated.
So for people that are new to the field, they can learn about a lot of these details that can seem like a substantial barrier through taking advantage of some of our education workforce development, courses, whether it be online courses or some of our workshops. But, also it sounds like, we're an accessible facility, and you're also willing to talk to potential customers, answer questions like that. You consider, what we offer to be fairly accessible.
I actually encourage customers who are new to testing, come visit us at TAP. We could show them our test equipment, how we do these tests, because a lot of times they're unfamiliar with how it's done. A lot of customers design these photonic integrated circuits within simulation software, do various calculations, but they never see how it's actually tested. And that's when you discover the hurdles and the,
challenges, right?
Challenges related to testing. So especially when they're testing and we have an issue with it, the customer can come on site with us. I can work with them, work through those problems. So it's not just like a cookie cutter operation. It's, we want to help the customer work through these challenges and have them have a successful device.
Great. Are there any unique tools, approaches, capabilities that AIM Photonics provides that aren't typically available to most companies or university labs?
Sure. Anytime you introduce light into electrical test equipment, there is a significant increase in cost. And for many groups, that can be challenging to obtain all the necessary equipment to meet the test capabilities. And RF testing alone costs upwards of $1 million easily. And if you want to go into, 100 gigahertz, you're going to double that. And then we have to talk about probing capabilities. If the customer needs an electro-optic prober, you're going to spend several $100,000 at a minimum just for the probe system alone. And, TAP in particular, we offer not only these test capabilities, but also the ability for the customer to package and assemble their picks. So if they want to package a few and take them back to their facility and test, they could also test there, and we could test at the same time at TAP and almost compare apples to apples. And that could be useful for a lot of debugging as well. Like I said earlier, customers are open to visit here at TAP and work with us in testing. And so, it's very helpful for them as a learning experience.
And it also sounds like it's a substantial advantage to have the fabrication and packaging capabilities co-located with the test capabilities, in times where you may encounter something unexpected. Sometimes being able to package or make a certain modification help what you do. But also, they have the ability to see the different parts of the assembly process and how that might really test it.
Absolutely. Oftentimes we test at the chip level or at the wafer level, and then we'll package that chip and then do the same testing again and kind of look at, how does the assembly and packaging affect the performance of the photonic integrated circuit? And this is especially important with RF, because when you add things like wire bonds, bumps, package interconnects, PCB fan out, all of this affects the RF performance, and it's important to understand that before and after the device packaging.
Yeah, it sounds like, and after it's packaged, obviously it's connectorized, and so they could actually get a preview of what results they can expect from driving those devices here at TAP. Takes that experience to their location and test their own equipment and see how it compares.
Yeah, absolutely.
And also potentially, preview equipment they may want to acquire, in their own lab. All right, can you share a real world example, without naming names, of course, of how our testing services has helped a user, troubleshoot, their designs or make improvements, early in the process?
Sure. This is an actual fairly common problem, but we did have a design come in for test, and it had several thermal optic fin shifters on it. And they're essentially heaters, but they're located all throughout the circuit, and there's some modulators here and there throughout the chip. The problem was that each of these heaters was affecting nearby components within the circuit. So they would add bias to one fin shifter, and it was affecting not only the ring next to it, but also the one adjacent, which it wasn't supposed to. And either this was something that was overlooked, or maybe it was underestimated in the simulation. But since this was the customer's very first design, this was their initial design they submitted with us, they were able to identify these issues very early in their stage and make corrections.
Excellent. I mean, that's the type of thing that, having this sort of close interaction to the lab that's doing the testing and being actually here to help, in this troubleshooting phase, be a substantial learning experience and accelerate development. What role does testing play in the broader development of emerging technologies like integrated photonics? And why is it such a critical part of innovation in the space in which we work?
Lightwave technology has actually been around for many decades now, and this really began to take off after the introduction of fiber optic communications and semiconductor laser diodes by 1970. We see it or we don't see it being used every day in smartphones, TVs, modern vehicles, transportation, in the medical field, hospitals, urgent care centers. The instrumentation used in medical facilities relies heavily on photonic devices. Lightwave communication, sensing, all of this plays a part, and that's just to name a few on the consumer end. It's ever growing in telecom and military applications, not only around the globe, but in space. I think NASA first used fiber optic communication when they were traveling to the moon in the late 60s. That was like one of the very first usages of fiber optic communication, using fibers to transport data. And, it's ever growing. Integrated photonics, this allows us to shrink the technology into smaller and smaller packages. They're lightweight, more powerful, compact, and we're making more and more discoveries of what can be done with integrated photonics. And that's, really comes down to the testing. We could run all the simulations in the world for a photonic integrated circuit, but it always comes down to the real world results. What is possible, what is not, and how to break through challenges that enable next generation of this technology.
Excellent. Well, thank you very much for sharing your expertise, for everything you do and working with our members and our customers. So, thank you very much for your time.
Thank you, Chris.
Thanks for joining us on Photonics in Focus. Be sure to subscribe and stay tuned for more deep dives into the latest advancements with industry experts throughout the integrated photonics ecosystem. For more information about AIM Photonics and the work we're doing to advance the integrated photonics industry in the United States, please visit our website at aimphotonics.com.